formulas that we established last time because there's a lot of them.
Grabe.
Well, overall, it's just a matter of getting used to them. So let's recall. Or kasi, imagine in other situations, what they do is they just give the formula. We could have done that, but I also wanted to present everything in a manner which shows that mathematicians didn't just come up with these. So there's a whole lot of effort, and then everything has to be done carefully. All right. So dapat nung reasons natin correct. Halimbawa, some of those identities involving the trigonometric functions of angles, you can come up with the result with the proof by assuming the angles are in a right triangle. Pero that would be insufficient because it turns out that these identities are true even if, for example, theta is negative or theta is more than 90 degrees. So it would go outside a right triangle. Just recall, the cosine of x plus y is equal to cosine x, cosine y, and then there's sine of x, sine of y. So cosines together and then sines together, but because the operation is addition, then it's subtraction here. And if it's cosine of x minus y, then the operation is addition.
Pwede na nga ba pong ilagay po parang ano nga po? Is it technically possible? Kasi pag plus, ay, yung ano pa naalala ko po nga, yung, kasi pag plus minus pa ambiguous eh. So, yung minus plus pa gagamitin. Ayun.
Yeah, minus plus. So as long as it's clear to you that the top symbols correspond to each other, the bottom symbols correspond to each other. Ito. Sine of x plus y. So sine of x, cosine y, and then here it would be the other way around. So sine of y, cosine x, and then the operation on the right side is going to be consistent. So if it's sine of x minus y, then it's going to be subtraction here. Now for tangents, the tangent of x plus y is going to be rational in appearance, tangent of x plus tangent of y over 1 minus tangent x, tangent y. Let me allocate some space here. If it's tangent of x minus y, then in the numerator, it's going to be consistent, but in the denominator, it's going to be switched. All right. Parang nung kasi tangent is sine over cosine. So in the numerator, you have sine. When you do the expansion, there's consistency in the operations. In the denominator, where you have cosine, you flip the operation in the denominator.
Abo.
All right. We also have the following double angle formulas. The cosine of 2x is equal to cosine squared of x minus sine squared of x. This is attained by taking the cosine of x plus 5 formula, letting y be equal to x. Alternatives are the following: 2 cosine squared of x minus 1, also 1 minus 2 sine squared of x. So from the formula with the star, you just replace cosine squared with 1 minus sine squared, or we replace sine squared with 1 minus cosine squared x. And each of those two strategies would lead to either of the two expressions below equation star. for sine of 2x, there is only one standard expression in the sine addition formula. Letting y be equal to x gives us sine of x cosine of x. The two terms in sine of x plus y will be the same, so this gets doubled. And then tangent of 2x is equal to, in the fraction, so x equals y this time, so we have 2 tangent of x over 1 minus tangent squared of x.
Abo.
Alright?
Ginagamit niyo po yung, commonly, ginagamit niyo ba po yung triple angles?
Triple angles, I am familiar with it. When the opportunity arises, I use it. I prove it. I suppose this is what you're talking about, cosine of 3x, diba?
Opo.
So this is, I'm aware pero hindi ko kabisado ng formula. Basta may 3 and then 4 na coefficients. Alright, gawin nga natin. This is cosine 2x, cosine pala. So cosine 2x and then cosine x.
So ganun na po talaga. Kasi you can just, alam niyo po yung double angle, so you can just add the other one na x.
Yeah, so it's all based on this, cosine 3x. So first break down 3x into 2x plus x. So actually this allows you to do it for, say, cosine of 4x, cosine of 5x. It's just going to be rather tedious, but that's ultimately how it's done. So ito, and then cosine of 2x and sine of 2x. Sine of 2x, let's replace it with 2 sine of x, cosine of x. Cosine 2x, we have 3 replacements, but for consistency, let's use the one involving cosine of x, 2 cosine squared of x minus 1. So now we have 2 cosine cube x minus cosine of x minus, now that's going to be 2 sine squared of x cosine of x, and then sine squared here can be replaced by 1 minus cosine squared of x. So what we are subtracting is therefore cosine of x minus cosine cube of x. That's what we're subtracting. So finally, the cosine of 3x is equal to, what's this going to be? Plus 1. So 3 cosine cube x minus 2. Oh, hold on. Sorry, I forgot. There's a 2 that needs to be distributed. This 2. So I do remember the coefficients are 3 and 4. And when it didn't end up being 3 and 4, that's what told me that there's something wrong. So this is 4 cosine cube x minus 3 cosine of x. Yeah. Sine of 3x, I'm sure, has something similar. I don't have it recalled to memory, but you can always do something like this. Okay. All right. Okay, so let's do some exercises using these. So this is January 26. Let me see what kinds of exercises we already did last time. So tangent alpha, cosine beta. Find tangent of alpha minus beta, find cosine of alpha minus beta. I suppose I could also have asked for not just alpha minus beta, but perhaps alpha plus beta, or maybe 2 alpha minus beta. Like, what's the tangent of 2 alpha minus beta? What's the quadrant of 2 alpha minus beta? So those things are other things that could also be asked. Let me see what I have here. So we did a proving exercise, yeah. I haven't written down additional, but at some point I should. I haven't gotten around to it yet.
Yung mga sa mathematical induction po na gawa na ni Joshua, pero hindi pa niya
Na-transfer. Okay na. So, and then, kunwari then say you want to take a break from the sessions, pwede din you could solve those problems too. In triangle ABC, okay. The triangle ABC be given. Prove the following. First, show that cosine alpha cosine B minus sine A sine B equals negative cosine of angle C. Okay, we have here three angles, but one thing that is most relevant here is that these three angles A, B, and C just aren't any angles, but they're the angles of a triangle. And because they're the angles of a triangle, what basic fact can we get out of that? That they form a triangle, the angles of a triangle.
A plus B plus C is equal to 180, so...
Right.
Yes, so... we can express all of them in literally just one. No, we can literally just two variables max. The C can be converted into A plus B.
Right. So in particular, 180 degrees minus A plus B. In fact, well, we typically start with the more complicated side. Here, we are going to start with the right side, the one involving cosine of C, because then that would be the cosine of 180 degrees minus A plus B. And then there's going to be an expansion there. Let's see if it's going to give us a left-hand side. So cosine of C is the cosine of 180 degrees minus A plus B. But how can we rewrite this? Cosine of 180 degrees minus the quantity A plus B.
Evaluate po. So, yung cosine plus, cosine plus naman. Sine. Okay. So,
yeah, all right. So there's that. However, the first angle isn't just any angle, it's 180 degrees. So my hint here is, Joshua, given cosine x and cosine 180 degrees minus x, what can we say about the cosines of two supplementary angles?
Oh, so 180, so the, wait lang. 180 is yung half rotation negative 1 is tapos minus x. So, this is x. And this is the supplementary angle. That's the reference angle. Because it's in the, it doesn't have to be the, yes, it is the reference angle. Kasi if it's in the first or second quadrant, it will still be the reference angle. So it's always positive.
Or, I mean, I suppose x could be in the second quadrant. It's possible, but say it's in the first quadrant. All right, x is in the first quadrant. Then you can try to imagine 180 degrees minus x, but these two cosines, how are they related to each other?
Negative? Wait lang. Let's say, I'll just give an example ba, 180 minus 45. 135. Cosine 135 is just basically cosine 45. Wait lang. X is negative.
So they're related to each other.
It's related po, pero it's negative. It's the negative of it.
They're negatives of each other. The cosines are the x coordinates of intersection of these rays with the unit circle, right? So here, the x coordinate is cosine 180 degrees minus x something. And then here, the x coordinate is cosine of x and then the sine of x. So as you can see, the x coordinates, the terminal points are reflections across the y-axis. So cosine x and cosine 180 degrees minus x are negatives of each other. You would have ended up with the same conclusion if you did expand cosine of the difference 180 degrees minus the sum of a plus b. All right, you would have ended up with the same conclusion, but this would be faster. This is the negative of the cosine of a plus b, in other words. And so finally, now we have negative cosine of c equals the cosine of a plus b. And then simply use the cosine. So yun na. Cosine A, cosine B, minus sine of A, sine of B.
How could I even not thought about that, bro? I already knew na it was cosine something plus something. I didn't realize it was cosine A plus B. All I had to prove plus B was the negative of cosine.
Right. Actually, ano dun parang if you look at the left-hand side, it's the difference. And then, hey, we have cosine, cosine, and then sine, sine, and then observe that the same angles A and B are involved. So actually, if you're going to try to work backwards, if you compare the difference on the left side with the formula, you'll observe that that's the cosine of A plus B. So pwede din. You could have started with that instead. Next. Tangent of A plus tangent of B plus tangent of C equals the tangent of A times the tangent of B times the tangent of C. So you have three numbers. Their sum equals their product, and those numbers are the tangents of the three angles of a triangle. So C is 180 degrees minus A plus B. So my question is, how are the tangents related to each other?
How are the tangents related to each other? Huh?
Yeah, tangent of X compared with tangent of 180 degrees minus X.
Okay, so tangent of 180 degrees. It's also negative, I think. 180. Yes, it also flips at the y-axis.
Yes. All right. Okay. Also negatives of each other.
The problem is how to get on it.
Well, sorry. Tangent of 180 degrees minus X. Well, as you said, didn't flip sila, but what exactly flips? Or ganito na lang. Is it clear to you that tangent x and tan 180 degrees minus x are negatives of each other?
About negatives of each other. Negations.
How would you argue it? Why are they negatives of each other?
Kasi the 180 minus 180 po muna, it only spans first and second quadrant. So 180 minus x is sure to be either in the first or second quadrant.
Okay.
If in case na x is smaller, or if x is in the first quadrant, it is sure na the 180 minus x will be in the second quadrant. If in case na naman na x is big and then it's in the second, it reaches into the second quadrant, the 180 minus x will just be in the second.
I see. So you are relating the signs. So you are coming here with the assumption that they have the same absolute values. It's just a question of, are they gonna have the same sign, or are they gonna have the opposite signs? So your argument is supportive of why they have negative signs. Yes, that's correct. Also, this is sine of 180 degrees minus x over the cosine of, all right, diba? Tapos, so we already talked about how cosine of 180 degrees minus x in the denominator is the negative of the cosine of x. What about sine of 180 degrees minus x? How is that related to sine of x? Are they exactly the same or negatives of each other?
Sine is positive in both first and second, so nothing happens. It's just the same. Positive, but
All right.
positive x.
So therefore, this is negative tangent of x.
How
All
could
right.
I
So
not thought about that?
all right. So again, I really wanted to be sure that you saw that. Okay. So mangyayari, again, back to the illustration here. So see how we always find ourselves back to this figure. Sine of x and cosine of 180 degrees. Let's use orange, using orange for that other point. These 2 points are at the same altitude, the same elevation. So same height from the horizontal. So that means the y coordinates are equal. So sine 180 degrees minus x and sine of x are equal to each other. Okay, so at least what we know is that tangent of C, because it's tangent of 180 degrees minus x, this is equal to, 180 degrees minus a plus b, then it must be the negative of the tangent of a plus b. So we have the negative symbol. Let's use the tangent angle addition formula. Tangent A plus tangent of B over 1 minus tangent of A times the tangent of B.
I can see the light at the end of the tunnel.
All right. Okay. So let's so we have tangent of C multiplied to 1 minus tangent A plus tangent B equals the negative of tangent A plus tangent B. So as you can see, this is all just really a direct application. So the left side is, oh wait, hold on. Not quite right yet. Oh wait, sorry. I see my mistake. Okay, with the many T's. All right, tangent B. So the left side is tangent C minus tangent A, tan B, tan C. Finally, rearranging, which you said you already saw as the light at the end of the tunnel. So here we go. Here it is.
Yes.
So 3 numbers equal, their sum being equal to their product, and that's for the tangents of the angles of a triangle.
Perfect.
Perfect ba yun nung ano? Di ba, not quite, a number is equal to the sum of its proper divisors. Yun ang perfect number.
Okay.
Like 6. Proper divisors niya, 1, 2, and 3. So, yeah, 1 plus 2 plus 3.
Abo.
All right. Ano pa ba? Here, I got. Oh, yeah, 28 is next. No, perfect number. I remember correctly. Ito,
Abo. So, prove that tangent. Oh no. 23 to the 0. 23 degrees.
Degrees. I'm going outside. I'm going outside. Sorry.
I got shocked na po when I saw degrees. I got so used to it.
Okay, regions. But anyway, I'm definitely going outside textbook exercises. Kasi if I'm just gonna like I mean, I think there are some exercises you would know how to do them on your own. So I'm giving you others which could be stumbling blocks. Ito, 1 minus cotangent 23 degrees equals 2 over 1 minus cotangent of 22 degrees.
Ano pa rin, do the, yung mga addition, angle addition, tsaka double angle, do they still work pag degrees?
Yeah. They're still gonna work with degrees because when we did parang ganito, no? So when let's say that this is pi over 6. So this angle is pi over 6. The usage of the radian measure has a direct impact on the arc length. So for example, because that's pi over 6, and if this is the unit circle, then that means itong arc na to, this arc, okay, the length here is pi over 6. But the coordinates of the terminal point, this one, they are going to be cosine of pi over 6 and sine of pi over 6. But well, the thing is cosine pi over 6, that's still cosine 30 degrees. And sine of pi over 6, that's still going to be sine of 30 degrees. So the relationships between the cosines of x and 180 degrees minus x, for example, the fact that they're negatives, so with x in degrees, so they're still true. And if you look at the radian version, cosine of theta, comma, cosine of pi minus theta, yeah, the same situation is still going to hold. They're going to be negatives of each other. So yes, in summary, to answer your question, these angle addition and subtraction formulas, they're going to still hold even if the angles are in degrees. All right, because cosine of pi over 6 is the same as cosine of 30 degrees. So if the cosine of pi over 6 is the negative of the cosine of 5 pi over 6, then yes, the cosine of 30 degrees is the negative of cosine 150 degrees still. Okay. Now,
variable. I just realized that.
Yeah, variables sila. So these identities, they're true. Halimbawa, when we were proving various trigonometric identities, like for example, this one, whether x is in degree measure or radian measure, this statement here that we proved will still be true.
Opo.
All right.
So therefore, this will be a rather easy problem. Kasi 23 is 22 plus 1. But
all right.
I just realized, hindi, pwede pala. 1 over cotangent x is equal to tangent x.
You're thinking of 23 is equal to 22 plus 1. That is certainly correct. So, however, yes, even though it's cotangent, but then, cotangent is just the reciprocal of tangent. So ultimately, if it's a question of dealing with tangent 23 degrees, okay, we are going to be able to explain that in terms of the tangent of 22 degrees and the tangent of 1 degree. However, we don't know the specific value of the tangent of 1 degree. And if you look at that statement that we need to verify, the tangent of 1 degree or its cotangent doesn't appear there.
Do we need to know ba?
But it's not a special angle. So actually we can't, even if we wanted to. But you know what? You're right. You tried to find a relationship between 23 and 22. 23 is 22 plus 1, but it may just be an issue of this is not the relationship between 23 and 22 that we need. So maybe there is another way of relating 23 and 22. That would be more useful.
23 plus 22 equals 45. Ah!
Yeah.
When I find a pattern that was not there. 23 plus 22 is okay, I see.
Yeah. All right. 23 plus 22
Let
equals.
let 22 equals x. Therefore, cotangent of 45 minus x. And then you'll just prove that it will become this 2 over 1 minus cotangent x. And then
Yeah.
this
All
x.
right.
I see.
All right. So you know what? Let's do that. Let's have a look at 1 minus the cotangent of 45 degrees. Or if you want, sige nga, para masanay tayo, balik tayo sa radians, pi over 4 minus x.
Yes.
1 minus 1 over tangent pi over 4 minus x. 1 minus. So we're going to take the reciprocal from the tangent subtraction formula. Tangent pi over 4 minus tangent of x over 1 plus tangent pi over 4 times the tangent of x. Pi over 4 is a special angle, and so we can figure out its exact value, which we know. The exact value is?
Opposite adjacent. Square root of 2.
But it's the tangent. So try again. 45 degrees. What's the tangent of 45 degrees?
It's 1 over 1. Because opposite is 1, and then the adjacent is also 1. 1 over 1.
It's 1. So 1. All right. So we have.
And I just found that right away na po.
All right. Kita mo na. So 1 minus tangent of x. This is going to give us 2. All right. And I think all we just need to point out here is that, hold on.
Realization. 1 minus tangent.
Minus, meron minus dito.
Why?
Kasi the numerator is 1.
I see.
Right.
It should not end up with 1 over tangent x. It should end up with 1 minus cotangent x.
Right. Okay. So, well, we could turn it into.
So 1 minus 1 over tangent. 1 minus 1 over cotangent x will be cotangent x minus 1 over cotangent x. So it will become negative 2 cotangent x over cotangent x minus 1 if I'm correct. And then what? Or you could take its conjugate. Is that possible? That would become second. Oh no.
Pero tingnan lang natin na still something seems to be amiss here. Or maybe but so far this is what I'm getting to. Cotangent x over 1 minus cotangent of x.
Wait. So, yun nga po. So what is something is missing. No.
Okay, kasi
there should be so it means actually we're so close. What is missing is that there should have been a cotangent x in the denominator. An entire factor of cotangent x.
But hold on. Let's like one more.
cotangent x minus tangent x over
Oh my gosh, hold on. It's all, kasi minadali ko ng algebra here.
Yung x niya, ano siya?
22.
It should be 1 minus tangent x, 1 minus tangent x, minus 1 plus tangent x.
What?
So it should have been minus 2 tangent x.
There, I see. So, kung gano'n nga po,
Alright.
it will remove the cotangent x sa taas.
Yeah. Ayun. Alright. So therefore, if x is 23 degrees, so we actually did something more general here. So therefore, 1 minus the cotangent of 23 degrees equals 2 over 1 minus the cotangent of 22 degrees. All right.
Epic.
Ito, try mo on your own. Subukan mo. If you could figure a way through here. Prove 4 cosine squared 9 degrees minus 3 multiplied by 4 cosine squared 27 degrees minus 3 equals the tangent of 9 degrees. And I think, I don't know if this would be, no, all right. Actually, I just found this in a list that I have, but I'm not sure how this...
When you need the triple angles now.
There's some things I'm seeing here. 27 is 999.
I can't get it out of my head. There must be another way.
3 times 27 equals 81.
Or 9 squared.
And yeah, and 81 plus 9 equals
90.
So we'll see. All right. Okay. I mean, because we should try to find a way of relating these angles to a special angle, much like what we did with 22 and 23 degrees earlier. Another challenging and difficult problem. I'm looking at a list of problems. I'm actually just listing them down. I'm looking at them. I'm not sure. Parang list lang siya, wala siyang solutions. But I may have seen something like this.
It's not problems po, tas nasa baba po from the IMO 2020.
No, this is not IMO. All right, don't worry. Okay, so we have a triangle ABC. So what we know is that 3 times sine of A plus 4 cosine of B equals 6. 3 cosine of A plus 4 sine of B equals 1. Find angle C. So all we know, so what we know is that A, B, and C are the angles of a triangle because the givens are in terms of A and B. So we are trying to figure out what C is. So therefore, we have to find a way of relating C to the angles A and B. And so far, all we know is that C is equal to 180 degrees minus A plus B. Okay, so we're gonna have to figure out what A and B are. Ganito. Let's go back to the two given equations. What do you notice from the two given equations?
They they just have switched from sine
Okay,
to cosine, and then the cosine became sine.
right, right, right. And the coefficients are the same. So
I
I don't think we're supposed to find A and B exactly, all right, because it's going to be difficult, all right. But to figure out a way of canceling something, we do know. Uh, can you tell me one way in which sine of A and the cosine of A are related to each other? Like,
they
okay, it's going to be tough for them that they're not going to be negatives of each other or they're going to be exactly equal to each other. But an equation
co-functions.
involving both sine of A and cosine of A, can you think of one?
They're co-functions. So
That
sine.
they're co-functions. And
Wait.
so,
So sine of 180 minus this is hindi. Kasi ano pala, nasa perpendicular ba sila? Hindi
so,
pa siya
so
supplementary. So,
yeah, oh, you can't really say that.
sine A is equal to 1, what? Sa- Sine 180 minus, what? Sine 90 minus A or sine pi over 2 minus A is equal to cosine A and vice versa.
Oh, yes, actually, that's correct. That's correct. Wait, is it really that? Hindi ba, I mean, if we were in our right triangle, and we don't know that we're in a right triangle, di ba? Para ang mangyayari, if this is x, so this is going to be 90 degrees minus x. So mangyayari, sine of x will be cosine of 90 degrees minus x. But then, well, sine and cosine, but the angles are different, x and 90 minus x. So I don't think it's the co-function relationship that's going to help us here. But
Sine
another
squared
equation
A.
involving sine A and cosine A.
Para po siyang, ano pong tawag doon? Explicit using only them. Without using any other. Baka pwede ba ng tangent? Pero, anyway, sine squared A plus cosine squared A is equal to 1.
Yeah. So let's square both equations.
Wait a
So
minute.
because then
I see the Pythagorean ano po, yung relationship. Magiging 5 the times 1.
so 9 sine squared A plus 24 sine of A plus sine of B.
Oh, I just realized you have to square everything.
And also when you square the second equation, 9 cosine squared of A plus, you see what's so fortuitous about this is that at least the coefficients are consistent.
And none of them can be factorized, so therefore you're left in the dust.
All right. Now, we now have two equations, and they're dying to be, what should we do with them? With these two equations?
They need to be added.
Right. The first column, 9 times sine squared A plus cosine squared of A, that's just going to be 9. The third column, that's 16. The right side, 37. Well, we still have a middle term. Sorry, 24. That's 37 minus 25, that's 12. But what is that?
That looks like wait, this is a sine A plus B. Yes.
It is
I think so.
sine of A plus B multiplied by 24 equals 12, which means
equals 1/2. 2 sine of what? Yeah. So what gives 1/2? Opposite over hypotenuse. Oh, so it's that a plus b is equal to 30 because it's the 30 degrees and the 30, 60, 90.
We're very close. So this is definitely the right way to use the two given equations. Pero, Joshua, this is where an awareness of, okay, ganito. You hypothesized a plus b is 30 degrees.
Wait, I have an idea po. Di ba po ganun? Kasi if two angles po na triangle are added, that's equal to the it's not the it's the supplementary angle to the remote wait lang po ah. So, di ba po sa yung mga remote angles are equal to yung sum of the remote angles are equal to the supplement of the third angle. So if a plus b is known to be if the a plus b is known to be 30, then it means the other angle is 150.
Okay. However, what I would need to question here is your conclusion that a plus b is 30 degrees. Is that the only possibility?
So since there are the sine a plus b is both positive in first and second quadrant.
Yeah.
Also, it is also true for 150.
A plus b is 30 degrees, or a plus b equals 150 degrees. All right. Maybe only one of these is true, and then maybe there would be a way to dispute the opposite. And to be honest, that would be the more difficult part. Why only one of these is true and the other is going to be false. Actually, well, if you know that a plus b is 30 degrees, then that means c is 150 degrees. And in the latter case, if a plus b is 150 degrees, that means c is 30 degrees. So we're very close there. We just have to figure out which of these would hold. Would only one of them be consistent with reality? Would one of them be something that we need to dispute? And so we are going to try to have to find clues in the two given equations. It's not so. This would be, to be honest, the more difficult part of the problem. So let me just go ahead and try to let's say a plus b is 30 degrees. So let me write it colored. So this is my scratch work. Suppose a plus b is 30 degrees. So that would mean A and B, both of them are greater than 0 degrees. Both of them are less than 30 degrees. None of them could be larger kasi hindi naman pwede that one of them is negative. Kasi that's also one thing we get out of the fact that we have a triangle here. So A plus B plus C, they add up to 180 degrees. Furthermore, none of these three angles is 0. None of them is negative. So if they're all positive and A plus B add up to 30, then that means A and B individually are less than 30. I'm starting with this case. The sum is 30 because if A plus B is 150 degrees, then that gives me a rather large interval for A and B to fall in. So mamaya na yan. Maybe A, B less than 30 degrees. Maybe I can find a contradiction there. So let's take A. Let's say A is 0 degrees, 30 degrees. What can we say about the sine of A and also the cosine of A?
So if A is less than 30 degrees, but it's also not 0, that means it is in the first quadrant. So sine of A is positive, whereas cosine of A is also positive actually.
All right, but what about
We can also know their value. Kasi sine A must be of course less than 1/2. And then cosine A should be less than uh, square root of 3 over 2.
itong point na to, what are its coordinates?
Okay, so square root of 3 over 2 and then 1/2.
All right. Kasi cosine of 30 degrees, you're right. And then sine of 30 degrees, 1/2. Now, A is between 0 and 30 degrees.
So therefore, it must be less than square root of 3 over 2. But also greater than.
All right. So let's talk about cosine of A and sine of A. So if you compare that blue point and the orange point, what are the best inequalities that we could supply? Let's start with, well, why don't we start with cosine of A?
So cosine of A must be greater than square root of 3 over 2, but less than 1.
Right. Okay, so you're right when you said earlier cosine of A is greater than 0, but from the figure, this is what we get out of the fact that A is between 0 and 30 degrees. So that visualization was all we needed. So again, back to the unit circle. What about the sine of A?
So it is between 0 and 1/2. So 0 greater than 0 but less than 1/2.
Right. Greater than 0 and less than 1/2. So because A is between 0 and 30 degrees, and because B is also between 0 and 30 degrees, so in fact, we can come up with the same conclusions about cosine of B and sine of B. So similarly, cosine of B is larger than square root of 3 over 2, less than 1. Sine of B is larger than 0 and less than 1/2. All right. The cosine of 30 degrees, we know that to be square root of 3 over 2. Cosine of 30 degrees is square root of 3 over 2. But when you take the cosine of A, it doesn't mean cosine of A is going to be less than square root of 3 over 2. Because what happened is that cosine of A was actually greater than the square root of 3 over 2.
Abo.
So again, deciding greater than or smaller than, what helped me figure that out? That illustration, that vision. Again, back to the unit circle. Now, 3 sine A plus 4 cosine B. Let me write it down here. And then 4, well, 3 cosine of A. Four sine of B is equal to 1. Let's have a look at 3 cosine A plus 4 sine of B. This would be less than 3 cosine A is less than 1. 4 times sine of B times 1/2. So this is 5. On the other hand, this is greater than 3 times square root of 3 over 2. 4 times 0. But this is 3 square root of 3 over 2. And 3 cosine of A plus 4 sine B is equal to 1. Pwede ba yun? 3 square root of 3 over 2 is less than 1?
No.
No.
When the contradiction.
In contradiction. Ibig sabihin, A plus B equal to 30 degrees, impossible.
But we can also say that But just because this is false, does that mean the other one is true? Because what if
Ah, you're right. You're right. What if both of them are impossible? So ganito, let's say, uh, wait, assume uh, that a triangle ABC exists for which, ayan. Okay, so assume that a triangle ABC exists for which this is true. But actually, you're right. Ultimately, who's to say maybe no such triangle exists with those given properties? All right, but let's assume such a triangle exists. So of these two possibilities, at least one of them would have to be true.
lol?
So given that premise,
Ginawa
that
po,
assumption,
para,
it, I think when I gave this in a talk before, in my scratch work, in my preparation, naghanap talaga ako ng triangle for which the given conditions are all satisfied. So dapat C has to be 30 degrees. I will try to get back to you on that, but let's assume such a triangle exists. So A plus B equal to 30 degrees is impossible. At any rate, one of my goals here is to point out how if the sine of A plus B is equal to 1/2, you cannot just conclude that A plus B is 30 degrees because there's this other possibility that A plus B is 150 degrees. All right. So with sines, it's not as definite. However, you know what? My next question is what if we ended up with the cosine of A plus B equals 1/2? Would that have been an easier situation? Would we have been able to come up with a definite conclusion if our starting point is the cosine of A plus B is equal to 1/2? Ano sa palagay mo? Would it be the same as this? We're not sure. Or would we have been able to definitely conclude what A plus B is equal to
kasi if
without
sine
doing
is equal
additional
to,
work?
if sine is equal to A plus B, it could either be in the first or second
Yeah.
quadrants.
Oh.
If it's cosine, it means it have to be the first or fourth quadrants. But if it was in the fourth quadrant, uh, if it was in the fourth quadrant, what would happen? Nothing. Is there anything different that could happen?
Pwede bang nasa fourth quadrant ang A plus B?
Is there such a triangle that exists?
Yeah. A plus B is in the wala, di ba? Kasi either negative ng A plus B, which is not possible because A plus B is positive, or A plus B, if it's in the fourth quadrant, it's larger than 270 degrees. Eh, lampas ka na sa 180 degrees. So hindi pwede. So in this case, A plus B is in the first quadrant, no other possibility.
But if A plus B is in the first quadrant, it can't be 150.
Yeah, it cannot be, well,
Wait, so does
I
that
mean,
mean
ang
there's no
choice,
such triangle that exists?
no, wait, ignore sine of A plus B. I was saying, what if instead of sine of A plus B, this is our conclusion. Cosine of A plus B equals 1/2.
Whoa. I mean, so if it's equal to if cosine A plus B is 1/2, then that means it is now the 60 degrees.
Mm-hmm. All right, and we're gonna be sure kasi, but again, okay, let me clarify. Ganito, what I'm saying is that we did the squaring here, where we ended up with sine of a plus b equals 1/2. Unfortunately, while we had two conclusions, a plus b equals 30 degrees or 150 degrees, there was no automatic conclusion. We had to decide whether which of these two scenarios is impossible, leaving us with the only possibility. What I'm describing is, what if the work here, where we squared the equations and then added them, what if it led to this? So we didn't come up with sine of a plus b equals 1/2. Suppose what we ended up with is the cosine of a plus b equals 1/2. So my question is, would we have been able to come up with a definite conclusion, or would we also have to choose between two scenarios?
We don't have to choose between two scenarios po, pero
All right.
it's striking to me na if we just use a different method, the answer would change.
Pero kasi dito, we had sine A cosine B, and then cosine A sine B. So whether you add or subtract, that would have only led us to to the sine rather than the cosine. Kasi kung cosine of A plus B, it would have been cosine A, cosine B. They would have been what are involved. But when you square, hindi yun ang nakuha natin eh. So actually, as far as this problem is concerned, ito lang talaga nung feasible way of solving it. But at least it illustrated that with science, you have to make a choice.
Actually,
okay.
You don't have to do that way, because you can sort of switch them. If you add them beforehand, you can switch the cosine. Oh wait, you can. You have to add all of them.
Oh. You cannot add the two given equations. Say you would now have a sum of 4 terms, and when you square it, ang daming mga extra terms na ma-introduce, and we may not have a way of getting rid of them. So let me clean this up. Then 1, which is 3 cosine of A plus 4 sine of B to be greater than 3 cosine of A squared of 3 over 2. Sine of B is greater than 0. 3 squared of 3 over 2, which is impossible. Yeah. Thus, A plus B equals 30 degrees, not equal to. Therefore, A plus B is 150 degrees. Therefore, C is equal to 30 degrees.
Epic. So therefore,
all right.
Conclusion.
Okay. Other exercises.
When ano po, exercises pa lang. Oh no.
Or exercises examples. So tangent theta plus twice the tangent of 2 theta plus 4 times the tangent of 4 theta. So what we're seeing here is a sum of tangents involving the angle theta, and then theta inside the tangent is multiplied, and the tangent itself is multiplied by the same constant. And these constant multipliers are, in particular, powers of 2. So increasing from 1, 2, 4, 8, until 2 to the power n minus 1, where n is an arbitrary positive integer. And apparently, this sum of n terms show that it's always going to be equal to the following simpler looking difference. The cotangent of theta minus 2 to the n times the cotangent of 2 to the n theta.
Simpler looking.
Yeah.
It also
The difference, because on the right side, it's just 2 terms. The left side, as n varies, there will be more and more terms on the left side. But on the right side, that difference just consists of 2 terms. Any ideas on how to
any positive integer n. You could just use the double angle over again, but wait.
Actually, this is so tangent theta plus 2 tangent 2 theta. So this is when n is equal to 2. So cotangent theta minus 4 cotangent 4 theta. And then when n is equal to 3 plus 4 tangent 4 theta equal to cotangent theta minus 8 cotangent 8 theta. So parang with one stone we're hitting infinitely many birds here, all right, because n is changing. So what general proof technique can we use here?
For every difference, there is always a conjugate, but will that lead to the correct answer? 1 over cotangent become tangent minus 2 tangent 4 theta. No, 4 tangent 4 theta.
Let's prove this by what general
induction? Kasi
yes.
if you use I was just thinking po if you have this type of question, is it possible to use induction?
Kasi, definitely.
Well, ano po, tapos maglalagay dapat po kayo may absolute value tsaka para ultimate.
But this is math induction kasi yun kaya ko nga sinulat that we are trying to prove here general property where among these statements they are determined by a particular value of n. So prove this by math induction. So part 1, when n is equal to 1, the left hand side is 2 to the 0 tangent theta. So it's just the singular term tangent of theta. On the other hand, the right hand side will be the cotangent of theta minus, and then when n is equal to 1, that's 2 cotangent 2 theta. So the question is this going to be equal to tangent theta? Let's see. We have 1 over tangent theta minus 2, and then over the tangent of 2 theta. minus 2. And then from the double angle formula for tangents, this is 2 tangent theta over 1 minus tangent squared theta. So, or if you want, if you're still getting a hang of it, tangent to theta is tangent theta plus theta. So it's a numerator, tangent theta added to itself over 1 minus tan theta multiplied to itself. So we see these twos disappearing. Then that's fun because now they have the same denominator, tangent theta, 1 minus tangent squared theta. That's going to be tangent squared theta over tan theta, which is just tangent theta, which is the left-hand side. All right. Okay, now why don't we use summation notation? Suppose for some positive integer n, we do have the summation. So we have 2 to the k minus 1.
Is it possible to have two summations in one po?
Ano yan?
Two summations in one. The summation of the summation.
Yeah, possible, but there would be 2 indices of summation. All right. Pero kasi ganito, if you look at the terms, the theta is not changing. What's changing are the exponents in the powers of 2. So we only need to have a single summation, k, from 1 up to n. So n here represents the number of terms. So cotangent theta minus 2 to the n, cotangent of 2 to the n theta. So what we want to do is show the following, that if n were to be replaced by n plus 1, so the change would just be there in the upper part of the summation, the terms are still going to follow the same format. 2 to the k minus 1, tangent of 2 to the k minus 1 theta. On the right side, cotangent theta minus 2 to the n plus 1, the cotangent of 2 to the n plus 1 theta. So you see what changed? N replaced by n plus 1. So in this statement that we have to prove, let's start with the summation. The given is this sum with the first n terms. So all we gotta do is take this sum with n plus 1 terms and separate the very last term from the first n terms.
No! Copy paste!
Yes.
Ay, so po, nakita ko po magsiselect na po kayo. Uh-oh.
No, I'm so weak. Alright. Dapat strong. Dapat walang copy paste. Alright. So when k is n plus 1, k minus 1, the exponent of 2 will be n plus 1 minus 1, so n. And then tangent of 2 to the n theta. And then this, from our assumption, is equal to, I am so ready to disappoint you because I think you know what I'm going to do next.
No.
Yes. yes, Joshua. All right. Okay, now OneNote is punishing me because I cannot select the color. Anyway, fine, sige. Plus 2 to the n tangent 2 to the n theta. So what we now have is cleaner. Now this is our target. Okay. We already have cotangent theta here. So what follows is where we need to work on. So cotangent theta, and then we want subtraction. The next two terms have a common factor 2 to the n. So let's already factor that out. So cotangent of 2 to the n theta minus the tangent of 2 to the n theta. So what this suggests is that we need to work on the expression inside the brackets. So, well, even though in the expression underlined in purple, we want just a single term with cotangent, I think it's more comfortable working with tangents. So let's rewrite the first term as 1 over the tangent of 2 to the n theta.
When you're working with tangents, but then the sine and cosine.
Wag naman. Try natin kung pwedeng tangent na muna. And then if we're stuck, then that's when we move to sine and cosine.
Looks familiar.
Yeah?
Oh no. I remember this. This will... Wait a minute. Yeah.
And 2x is?
And 2x is literally 1 minus tan squared x over the tan squared x over 2 yeah, it has to be 2 tan.
Yeah, all right. So ito, kasi, well, for tan 2x, there's a coefficient of 2, but anyway, that's just a constant coefficient. 2 tangent of x over 1 minus tangent squared of x. So if we let x be...
This the reciprocal, but then you multiply it by 2.
Right. So we need to have 2 down here. All right.
What? Posible pa po yan? When you put the is it possible to put the parentheses inside like cross the parentheses inside the fraction bar?
Oh, okay. Sige, let me just remove let me just reduce the fraction bar. Diba?
But it looks cursed kasi, parang...
I understand, pero ayoko mag-erase. Pero sige na nga. All right, I'm gonna do a concession. I've been copy pasting, so all right, I'll reduce the fraction bar. All right, so what we observe here is that tangent of 2 to the n plus 1 theta equals 2 tangent of 2 to the n theta over 1 minus tangent squared 2 to the n theta. And that's the reciprocal of what's inside the orange parenthetical group. So this is 2 over tangent 2 to the n plus 1 theta. So let's wrap this up. Cotangent theta minus 2 to the n, but there's 2 there, so but this is of course 2 cotangent 2 to the n plus 1 theta. So 2 to the n plus 1, because there's another factor of 2, cotangent of 2 to the n plus 1 theta.
Yes!
Okay, so therefore,
QED.
or, of course I'm not going to QED, I'm going to copy.
Bruh, when instead of when you don't put the when you have to ano po, when you have to copy paste, when all you have to do is just put QED.
Why write QED when all I have to do is copy paste? Logic, my friend, logic.
Logic.
Isn't my logic impeccable? um, okay. So we have that. Um,
Solve.
yeah.
Genius. There. Mod erat demonstrator. Eres Gibson Dimitri.
This is a little bit back down to earth.
Yes, yes, yes. When ano po, when the special angle.
Yeah, all right.
Tapos ito po yung mahirap. Kasi ito po yung third question. So, I don't trust my judgment either.
It could be a grand deception, right? Parang, yeah, you can't trust your senses anymore.
I got fooled once na po. I don't want to, I don't want to judge yung problem anymore.
Yeah. All right. Anyways, sine
This
of
is the
15
easy.
degrees and cosine 15 degrees. Maybe actually if you could like find one of them, you could find the other because of the fundamental Pythagorean identity. Like sine squared
Also,
15 plus cosine squared 15 equals 1. So ultimately we
but
just need one of them.
there are an infinite number of ways to solve this. First of all, if you have this, you can know, yeah, if you know kasi you know sine 30 degrees, so you can know sine 15 degrees. Also, you can use the half angle theorem, but it's cheating. Anyway,
Well, all right. I mean, you can use the half angle theorem, but did you want to talk about the half angle theorem? Sige, ganito na lang. Actually, that's where it's leading to it. Um, the half angle theorem, like I'm aware of those theorems, but I think I've decided ayoko na silang i-memorize. Or if I have need for them, I just use them. Just derive the statement. But I suppose think of it this way. You could use the half measure theorems, the half measure identities, but how would you prove them? Or rather illustrate the proof of the half-angle theorem by applying it to the task of finding sine 15 degrees and the cosine of 15 degrees.
when there's not just one problem, but there's two problems in one problem.
Yeah, hitting two birds with just one stone, or three birds, four birds.
Sine 15. Okay, so sine a plus b is equal to sine. That will be harder, to be honest.
So what sine of a plus b? How about sine of 2x?
Oh yes, easier.
Or maybe the cosine of 2x.
Cosine 2x seems simpler because it's literally just two cosine.
The thing with sine 2x is it's 2 sine of x cosine of x. If you look at the right side, dalawa ang involved sine of x and also cosine of x. But if you're going to look at cosine 2x, we have alternatives.
So the 2 cosine squared x minus 1 or the 1 minus... Which one's
Yeah.
better? Okay, so cosine 2x, cosine 30, what's cosine 30? Square root of 3 over 2. So square root of 3 over 2 is equal to these. So square root of 3 over 2 is equal to 2 cosine squared x minus 1 or 1 minus 2 cosine 2 sine squared x. Unahin ko muna kaya po yung yung cosine. So
Yes, yeah. Oh.
Square root of 3.
So ito, you could solve for cosine squared of 15 right away, di ba?
Abo. And then divided by 2. And then square root that. Oh, I have to the root. If I want to get the decimal approximation, I have to the root.
So wait, 1/2 of square root of 3 over 2 plus 1. So this is going to be over 4. And then square root of 3 plus 2. All right, this is cosine squared of 15 degrees. So that means cosine 15 degrees is plus or minus the square root of 4 is 2. And up here, it's the square root of 3 plus 2. But the cosine of 15 degrees cannot be two values. It can only have one value, which is which?
So it is positive because it's in the first quadrant.
All right. So therefore, the cosine of 15 degrees is the square root of 3 plus 2 over 2. All right. I think for most purposes, this is going to be acceptable. However, I noticed one thing, which is that this is inside the radical 2, and then you have 2 square root of 3 plus 4.
Is that possible to the root?
I merely replaced the numerator.
O kala ko po, de-root po natin eh. Na-worry po ako eh.
Pero tama, at least algebraically. 2 square root of 3 plus 4 over 2 is equal to the encircled green square root of 3 plus 2, right? But in case you're wondering, why did I rewrite the radicand in such a manner? Well, because we have 2 square root of 3 plus 4 is equal to the following. 3 plus 2 square root of 3 plus 1.
Oh, it's a square.
Yeah. The square of the square root of 3 plus 1.
Wow. So it's possible to deroot it.
So sometimes it doesn't happen like that, but I just happen to have seen it. So meron tayong square root of 3 plus 1 over square root of 2 and then over 2. So if we want to rationalize it, so over 4 and then square root of 6 plus the square root of 2.
It was derooted! The nested roots have been gone. Have begun.
I noticed we could have avoided like maybe from here pa lang kasi we were anticipating having to take a square root. Dito pa lang, maybe we could have already rewritten it like as such. Kasi the transformation I did on the square root of 3 plus 2 over 4. So I doubled. So dito pa lang, 4 plus 2 the square root of 3 over 8 na kaagad. So this would now be square root of 3 plus 1 squared over 8. So para pagpunta dun sa next step, so yun na, square root of 3 plus 1 over 2 square root of 2. Positive, kasi positive na cosine of 50 degrees.
Okay, so 1 down. Easy.
And then, so we use this. So that's how an identity like this is useful. So the second, we could use that.
Or the Pythagorean.
Oh, Pythagorean or the second. All right. So cosine of 15 degrees is, cosine of 30 degrees is square root of 3 over 2, which is 1 minus 2 sine squared 15 degrees. That means sine squared of 15 degrees, merong 1/2, then 1 minus square root of 3 over 2. So we have over 4, 2 minus the square root of 3. And then let's multiply by 2, so that in the numerator, we can write down a perfect square. 4 minus 2 square root of 3. And 4 minus 2 square root of 3 is the square root of 3 minus 1 quantity squared over 4 times 2. And then sine 15 degrees is positive. So sine 15 degrees is square root of 3 minus 1 over 2 square root of 2.
Easy.
Square root of 6 minus square root of 2 over 4. Yeah.
Wait, so it is again just the conjugate of cosine of 50.
Apparently so. Apparently so. Also, another way, because we already have ganito nga, no? Alternatively, sa ang dami, kasi from the fact that sine of 30 degrees is 1/2 and cosine of 15 degrees, because we happen to have already been provided this. We got it from earlier, cosine 15 degrees. Instead of using the Pythagorean identity, 1/2, which is sine of 30 degrees, where 30 degrees is double 15 degrees. This is twice sine of 15 degrees, cosine of 15 degrees. And so if we are trying to figure out what is sine of 15 degrees, we could use what we know about cosine of 15 degrees. Square root of 6 plus the square root of 2 over 2. So that's how we end up with, wait, hold on, over 4 pala dito for cosine 15 degrees.
So therefore, it is possible to find cosine and cosine of 7.5.
Yeah, it's possible. So actually, you could go on taking half and half and half and half. So meron tayong 1/2 equals sine 15 degrees plus square root of 6 plus square root of 2 over 4, so 2 na lang to. So that's how sine 15 degrees is actually 1 over the square root of 6.
Wait, since this is possible po, does this mean we can technically, oh, wait. Ito ba? So, sine, if, sine 0 degrees is just 0. So, is it possible possible to find the values of them, the zeros, by just using the limit of the just halving and halving and halving.
Ano yun?
You can just find the limit po of the halving.
Well, yeah, mangyayari because the sine is a continuous function. Their sines will be going down to zero. Mga sine 15 degrees, sine 7.5 degrees,
Yung cosine
sine.
naman po, will it approach 1 pag ginagawa niyo pong ganun?
Yes, that's true. Kasi well, basically mangyayari, ang magiging limit ng mga ito, sine of 0 degrees, which is 0. And as for the cosines, they will increase towards 1. I mean, after all, sine squared 0 degrees plus cosine squared 0 degrees equals 1. So if ito papunta sa 0, then this other term should be headed towards 1. Because the sum of the squares should be 1.
So I have accepted the challenge po. I will
investigate, or at least verify. So also, well, we can divide 30 degrees. We can also divide 45 degrees. So I can take the sine and cosine of 22.5 degrees, 11.25 degrees. I'm just not sure if they can be computed in a nice manner as we did here, the mga square roots.
0.99999665. So it's almost 1. How long can this go? 1. Yes, it approaches 1. Okay.
It should, right? All right.
Above. Literally Reynolds syndrome. Ay, Reynolds phenomenon.
One option here is the double angle formula for the tangent. Tangent 2x is 2 tan x over 1 minus tangent squared x.
If there's a triple angle formula, is it possible to find the third angle formula? Or
depende na lang sa kind of equation that's gonna show up. At best, that could show you an equation which the values would satisfy, but whether you could actually solve that is a different issue altogether. Ito, for example, ito, x is, let x be theta over 2. So therefore, tangent theta equals 2 tangent theta over 2. 2 tangent theta over 2 over 1 minus tangent squared theta over 2. Hinahanap natin ng ano ng tangent theta over 2. Let r be tangent theta over 2. So we get the equation with tangent theta is 4/3. So 2r over 1 minus r squared. So we get 4 minus 4r squared equals 6r. Actually, not so bad. It's quadratic. We could solve for r.
Easy.
So 2r squared plus 3r minus 2 equals 0. And is this even factorable?
Imagine factoring it. Just use ano po, completing the square.
Okay, complete the square. magkaka-3 halves pero that, but
Ah,
R,
-2. So,
yeah. So R is 1/2 or R is -2. The tangent theta over 2 is 1/2 or tangent theta over 2 equals -2.
how do you know which is which? Or
Yeah, which is which?
are they both true?
And have we used all the givens?
Cosine theta is below 0. Oh, so it must be negative. Oh wait, no. What if sine is -2? If tangent is positive and cosine is negative, so if tangent is positive, that means it is in the there's the problem with me, the tangents. Anyway, cosine is negative in second and third, while tangent bilang. So cosine negative second, third, tapos sine is negative third and fourth. So it means tangent will be positive in first and third. Therefore, it must be in the third quadrant. If it's in the third quadrant, then tangent will be positive. Therefore, it is 1/2.
What's our conclusion about theta? Theta is in which quadrant?
Third po.
Quadrant 3, right? Because tangent is positive, so that means first or third quadrants, but cosine is negative, so it must be the third quadrant. However, when you look at theta over 2, pwedeng yung theta over 2 nasa first quadrant or nasa second quadrant.
So therefore, it can be both negative or positive. So
But it can only be one, which means that we have to use the clues. We have not yet the full power of the clues available to us. Maybe the fact that tangent theta is equal to 4/3 would provide us with something better.
opposite over adjacent. So opposite is 4. So I can see the Pythagorean triples 3, 4, 5. So the opposite will be 4, and then will be over 3. Adjacent is 3. So therefore, it is actually, yeah, it's the this angle in the 3, 4, 5. The bigger angle, but not the right angle.
What are sine and cosine of theta at least? We could find them, right? Sige, babalik tayo sa tangent theta. Okay. So question dito, which one? This should all go.
The arctan of 4/3, but
Let's not do the arctan of 4/3 because let's say we don't have a calculator. Let's have a look at sine and cosine. So starting with tangent theta equals 4/3. Let's ignore theta over 2 for now. Let's try to complete the picture for theta, sine and cosine.
so sine is, how do you know actually? Because it could be either positive or, if cosine is negative, then therefore sine is negative too.
Yeah. So both sine and cosine are negative, but the value. Let's figure out the value of either sine theta or cosine theta. The values themselves.
Oh no. So
Do you remember?
it must be in the third quadrant. Sine and cosine must be in the third quadrant.
Yeah, that's the third quadrant, but the values themselves, the exact value. Sine theta equals what? Cosine theta equals what?
Oh no.
Let's go back to the Pythagorean identities. What can we use?
Sine
Yeah, but what's given is tangent theta.
Oh, so I can just do 1 minus tangent squared theta equals secant squared theta. And then I'll
Or
just
it's 1 plus tangent squared. All right. Secant squared theta.
1 plus 4/3 squared. And then I will just get this. Oh, no. I will have to reciprocal.
So what's cosine theta?
Plus minus. Oh, it can't use plus minus. It has to be negative. So 3/5. Negative 3/5.
All right. Since cosine theta is negative, tapos all right, which means sine theta is tangent theta cosine theta. So we have 4/3 times negative 3/5, which is negative 4/5. All right, but how do we figure this out? So a way out would be possible. Okay. Kaso lang in this case, mahirap. So let's go back to this. Balikan natin to. All right, balikan natin to. In figuring out the sine of 15 degrees and cosine 15 degrees, we used the double angle formulas for cosine effects. Okay, so balikan natin. Cosine of 2x is 2 cosine squared of x minus 1, from which we get cosine squared x is equal to 1 plus cosine of 2x over 2. Cosine 2x is 1 minus 2 sine squared of x, from which we get sine squared of x is equal to 1 minus the cosine of 2x over 2. All right, and then whether it's plus or minus when we get the square root ultimately depends on what we know about the quadrant of x. Only then will we be able to decide the angle. All right. So, only then will we be able to decide on the sine. However, there is a formula that I would like to present. It's not as well known as the others. Okay. Tangent of x, which is sine of x over the cosine of x. Right? And then I'm going to do something here. I'm going to multiply by 2 cosine of x.
Why? Whoever discovered that had no other time, and then there's this.
Yeah, so nothing else to do.
Okay,
Yeah.
he just decided to wake up, and then he said, I will just multiply everything by 2 cosine x over 2 cosine x.
Pero kasi ganito. Here we have a way of writing the cosine of x in terms of twice the angle 2x. Ito, x, 2x. Can we do the same for sine of x? Yeah. Here on the left side, sine of x is involved, and then on the right side, a trigonometric function of 2x. Now, we want to do something similar with tangent of x. Well, one of the basic starting points with tangent of x is to write it as sine of x over cosine of x. But we still have trigonometric functions of x. Now, we want to rewrite the fraction on the right side so that 2x, the angle 2x is involved. So one way of doing that, kasi if you have sine of x, so observe what would happen if you multiply it by 2 cosine of x. It would be 2 sine of x cosine of x, but recognize what that is.
It's the yun nga po. That's sine 2x.
Sine of 2x. So it is precisely 2 cosine of x that would have to be multiplied there. That will give us in the numerator sine of 2x. Of course, possibility then, you could have maybe considered the following. You're gonna do your, I know you're a fan of this.
No, I'm not. I'm the exact.
Yes, you are. Yes, you are. Yes, you are. You're just in denial. All right, so it's a sine of 2x. In the denominator, 2 cosine squared of x. So matutuloy pa natin yan, but here, well, instead of multiplying by 2 cosine x over 2 cosine x, we could have multiplied by 2 sine x. All right, because when you do that, it's the denominator, cosine of x times 2 sine of x, that would become the sine of 2x. Well, of course, the numerator will be 2 sine squared of x. However, from our two formulas above, we can actually replace 2 cosine squared of x here with from formula star, 2 cosine squared of x is 1 plus the cosine of 2x.
No.
And from formula double star, ito will give us 1 minus cosine of 2x. So here we go. We have sine of 2x over 1 plus the cosine of 2x. Alternatively, tangent of x is equal to 1 minus the cosine of 2x over the sine of 2x. Let's now go back to what we were doing earlier. Okay. Back to tangent of theta is 4/3, cosine theta is negative. Find the tangent of theta over 2. Let's use the first new formula, let x be theta over 2. The tangent of x, tangent of theta over 2, equals sine of 2x, sine of theta over 1 plus the cosine of theta. But didn't we actually figure out what the sine and cosine of theta are exactly? Cosine theta is negative 3/5. Sine theta is negative 4/5. So both negative, sine of negative 4/5, cosine is negative 3/5.
First time na ginamit po yung highlighter. Yay.
Yay. 1 minus 3/5. Negative 4 over 5 minus 3. Negative 2.
What?
And just like that, we actually know which one, but via that other solution, because we're going to decide tangent theta over 2, is it 1/2 or is it negative 2? But, well, it turns out by that other method, it parang some matter of which one you realize you could use. All right, so here you go. So it's actually negative 2. Tangent of theta over 2 is negative 2. It's parang difficult to figure out by just analyzing the quadrant of theta. Kasi theta over 2, it could be in the first quadrant or second quadrant. It turns out because tangent theta over 2 is negative, then theta over 2 is in the second quadrant pala. Alright.
Epic.
Or before we leave, ganito never mind. All right, sige. I thought I would think of another.
What? Another. Manala po.
No, wala na.
Wala po
I
yung
think.
mga examples. Tapos na. Yung ano kaya po yung mga problems. Oh no. We have to prove the quadruple angle theorem and the triple angle theorem.
Kaya yan. Ganito. You don't have to write everything in terms of just x. Try to find a way of relating the angles on the left with the angles on the right. Okay, ganito. Of course, find an easy way of relating them. Parang kanina lang, 22 plus 23. Well, 23 is 1 plus 22, but that wasn't really helpful. What turned out to be more helpful was observing 22 plus 23 equals 45. Now, we have 4 angles here, 2x, 4x, 3x, and x. But if you look at the left side, you have 2x and 4x. And on the right side, 3x and x. So,
I said po, may ano po 2x cosine x.
Actually, ito, 2x and 4x. Can you try to relate it, each of these in terms of 3x and x?
So, 2x plus 4x is equal to 2 times 3x.
Okay, 2x plus 4x is 2 times 3x. All right, that's one way. Pero so that you're also able to involve x itself. Kasi if you add them, well, 2x plus 4x is, just going to involve 3x. But how about, well, I mean, that's the sum. Well, what about the difference? 4x minus 2x.
4x minus 2x is equal to 3x minus x.
3x minus x. But in the same way that 2x plus 4x is double 3x, 4x minus x is double x.
Oh, okay.
Actually, ganito. 4x is 3x plus x.
2x is literally...
What about 2x?
2x is 3x minus x. When the conjugate.
So yun, it's things like that you could set your sights on rather than kunwari gagawin mo ng sine of 2x mahaba na puro sine of x cosine of x. Tapos yung sine of 4x parang ibababa mo all the way down to sine x cosine x. That's going to be rather tough if you're going to do that with sine of 3x all the way down to just 2 sine of x and cosine of x. So madaming it's going to be lots of expressions involved, but what if you make that realization and observe that sine of 2x plus sine of 4x is equal to the following. Sine of 3x minus x, and then the sine of 3x plus x.
Literally conjugate.
So, well, now you have the sine of the difference of two angles plus the sine of the sum of two angles. And observe that on the right side, that's going to be cleanly something in terms of 3x and x, which is what we see on the right side of what we're trying to prove. Okay?
Hey, QED.
QED. Well, I mean, do the work, finish it. So let's stop here.
Do you need to do the work and finish it? Because 3x minus x is obviously 2x. Ewan, joke lang.
Hindi, I mean, we're starting with the left side. We're starting with the left side. Paano natin palalabasin? This is the target.
I can see the light.
Pakita. All right. Yeah. All right. So, all right. So we'll end here, and I hope you enjoyed with the copy pastes most especially.
Why?
That's the highlight of our session always.
Ang galing po no? Yung pong we were exactly looking for somebody like you po. Kasi po yung iba, di ba, ano lang yung based from the book and formula lang siya. Sa substitute.
Yeah.
Exercises lang this one.
Oh, exercises lang. Ganun. But I think ito na exciting talaga.
Ito po exciting talaga.
Yeah. Lots of things.
That's
all right.
Copy-paste.
Okay. All right. Anyway, I gotta go. I have a meeting next. All right. Bye.
Bye-bye po.
Yes, sir. Bye-bye.
Bye, Joshua, Sergey.